class 11th chemistry. We were discussing unit 8 redox reaction, and in this video we'll discuss about balancing of redox reactions by oxidation number method. First of all, we'll discuss the different steps of this method. Step 1. Write the ionic skeletal equation. Step 2. Assign the oxidation number to all elements in the reaction and identify atoms which undergo change in oxidation number in the reaction. Step 3. Calculate the increase or decrease in oxidation number per atom and for the entire molecule or ion in which it occurs. If these are not equal, then multiply by suitable number so that these become equal. Step 4. Balance the charge. Balancing of charge depends on the medium of reaction. If the reaction is carried out in acidic solution, use H plus ions in the equation, and if in basic solution, use OH minus ions. And the last step, step 5, balance the number of hydrogen atoms by adding water molecules to the reactants or products. And when we balance the hydrogen atoms, oxygen atoms are automatically balanced. These are the steps. Now we will discuss the some questions. Problem 8.8. Write the net ionic equation for the reaction of potassium dichromate 6, formula is K2Cr2O7, with sodium sulfite Na2SO3. This is sulfite, okay, in an acid solution to give chromium 3 ion and the sulfate ion. Step 1. Write the skeletal ionic equation. Reactants are potassium dichromate. In this, dichromate is the ion which undergo change in oxidation number. And in sodium sulfite, SO3 is the ion in which there is a change in oxidation number. Okay, so Cr2O7 2 minus plus SO3 2 minus. And products are chromium third ion, that is Cr3 plus, and sulfate ion SO4 2 minus ion. Step 2. Assign oxidation numbers and find out oxidant and reductant. Okay, to assign the oxidation number, we follow the rules for calculating oxidation number which we have discussed in the previous video. Okay, now in case of Cr2O7 2 minus, oxidation number of oxygen is -2. And to find out the oxidation number of chromium, we use the rule that in case of polyatomic ion, sum of the oxidation number of all the atoms is equal to charge on that ion. Okay. In this way, there are 2 atoms of chromium and assume that oxidation number of each chromium atom is X. Okay, then 2X plus 7 number of oxygen atoms and each oxygen atom having oxidation number of -2. And this is equal to charge on this dichromate ion, that is -2. If we solve it and find out the value of X, then this will come +6. Okay, so oxidation number of each chromium atom in Cr2O7 2 minus is +6. Now in SO3, oxidation number of oxygen is -2, and for sulfur it will come +4. Chromium 3 plus, this is a monoatomic ion, so whatever the charge on this is its oxidation number. So oxidation number of chromium 3 plus is +3. In case of sulfate, oxidation number of oxygen is -2, and for sulfur it will come +6. Okay, now see in which atoms there is a change in oxidation number. So you will see chromium +6 changing to +3, decrease in oxidation number, that is reduction. So species which undergoing reduction is called oxidizing agent. So we can say dichromate ion is oxidizing agent or oxidant. Now in sulfur, +4 to +6, increase in oxidation number. So we can say oxidation is there. And the species which undergo oxidation is known as reducing agent or reductant. So we can say SO3 2 minus is reductant. Yeah, and there is no change in the oxidation number of oxygen. Now step 3. Calculate the increase and decrease of oxidation number and make them equal. Now let us once again see change in oxidation number. For chromium, per atom plus 6 to plus 3. Okay, so we can say there is a per atom decrease in oxidation number is 3. But in Cr2O7 there are 2 atoms. So in product side there should also be 2 atoms of chromium. So write 2 here. In this way total decrease in oxidation number is 6. Per atom is 3 and for 2 atom it is 6. Now what is the total increase in oxidation number? Sulfur plus 4 to plus 6. There is an increase by 2 and there is only the one sulfur atom in the reactant side. So total increase in oxidation number is also 2. Now this total decrease and increase in oxidation number we have to make equal. How can we make it equal? This is 6 and this is 2. If this is multiplied by 3, then we will get 6 both sides. Okay, so in this way the species which are involved in increase in oxidation number are multiplied by 3. So we will put 3 here and 3 here. So our net equation becomes Cr2O7 2 minus 3SO3 2 minus 2Cr3 plus 3SO4 2 minus. Clear? Now step 4. Balance the ionic charge. As we discussed, ionic charges are balanced by adding H plus ion because this reaction is taking place in acidic medium. Okay. Now first we will calculate the charge on both the sides. Now in case of Cr2O7 2 minus, there is 2 negative charge. In SO3 2 minus, each SO3 sulfide ion carry 2 negative charge and there are 3 sulfide ions. So total charge is 6 negative. In the product side, each chromium ion carry 3 positive charge and there are 2 chromium ions. So total positive charge is 6. Each SO4 2 minus carry 2 negative charge and there are 3 SO4 ions are there. So total negative charge in SO4 2 minus is minus 6. Now add this minus 6 and a minus 2, it is minus 8. Okay, and in the product side this is plus 6 and this is minus 6, so this is 0. Okay, now we have to add H plus. Now in which side and how many H plus we have to add to make charge on both the side equal? So we can say in the reactant side we have to add 8 H plus. Is it clear? So our reaction becomes Cr2O7 2 minus plus 3SO3 2 minus plus 8H plus converting into 2Cr3 plus 3SO4 2 minus. Clear? And last step, step 5, balance hydrogen atoms. And hydrogen atoms are balanced by adding water molecule. So just first we calculate the hydrogen atoms on both the sides. Okay. So in the reactant side, just see where is the hydrogen in this. 8 hydrogen atoms are there. Okay, and in the product side there is no hydrogen atom. So to balance the hydrogen atoms we have to add the water molecule, and to balance 8 hydrogen atoms we have to write 4 H2O on the right hand side. Okay, add 4 H2O on the right hand side. So our final equation becomes Cr2O7 2 minus 3SO3 2 minus plus 8H plus converting into 2Cr3 plus 3SO4 2 minus and plus 4H2. Clear? Once again you can verify that all the atoms and charges are balanced or not. Just once again see chromium in the reactant side 2, product side 2 chromium atoms are there. Okay, then sulfur in the reactant side 3 sulfur atoms, in the product side again 3 sulfur atoms. Now just see the oxygen, 7 oxygen are here, and in SO3 2 minus, each SO3 2 minus contain 3 oxygen atoms and total 3 SO3 2 minus, that's why 9 oxygen atoms are there. So we can say total oxygen atoms are 16 in the reactant side. Now in the product side, this SO4, total number of oxygen atoms in 3 SO4 2 minus is 12. How? This is 3 into 4. Okay, and the water molecule, there is 4 oxygen atoms are there. So 12 plus 4, 16. Both sides 16 atoms are there. Now hydrogen in the reactant side 8 hydrogen atoms are there. In the product side again this 4H2, 8 hydrogen atoms are there. So all the atoms are balanced. Now again C charge. This is 2 negative and this is In SO3 2 minus, 3 to just 6, 6 negative. And in 8H plus, this is 8 positive. So we can say minus 2, minus 6 plus 8. In the reactant side, 0 charge is there. In the product side, Cr3 plus multiplied by 2. So we can say plus 6 is here. And in SO4, 2 minus multiplied by 3, minus 6 is there. So plus 6 minus 6, 0. Both the side, charge is also balanced. So this is our balanced equation. Okay. Now let us see one more problem, 8.9. Permanganate ion reacts with bromide ion in basic medium to give manganese dioxide and bromate ion. Write the balanced ionic equation for the reaction. Step 1. First we write the skeletal ionic equation. This is permanganate ion, it is MnO4 minus. Bromide ion, this is Br minus. Gives manganese dioxide, MnO2. And bromate, formula of bromate is BrO3 minus. Clear? Now step 2. Assign oxidation number and find out oxidant and reductant. So for MnO4 minus oxidation number is minus 2. And if we calculate for Mn, it will come plus 7. Okay. For Br minus, oxidation number is minus 1. For MnO2, oxidation number of oxygen is minus 2. And on the calculation, we will get oxidation number of Mn is plus 4. For BrO3, oxidation number of oxygen is minus 2. And after calculation, we will get for Br, it will come plus 5. Okay. Now just see the change in oxidation number. This Mn plus 7 to plus 4. Decrease in oxidation number. So this is reduction. And substance which undergo reduction is oxidizing agent or oxidant. So we can say MnO4 minus is oxidant. Now in Br minus, from minus 1 to plus 5, increase in oxidation number. It means oxidation is taking place. So we can say Br minus is reductant. Clear? Now step 3. Calculate the increase and decrease of oxidation number and make them equal. Now in case of Mn, this changes from plus 7 to plus 4. Okay. And there is one atom of Mn in reactant side. So per atom change is 3 plus 7 to plus 4. So we can say total decrease in oxidation number plus 3. Now see the increase. This is from minus 1 to plus 5. What is the change? Minus 1 to plus 5. This is 6. So we can say total increase in oxidation number is 6. Decrease is 3. Increase is 6. To make it equal, this 3 is multiplied by 2. So whatever the species which are involved this in decrease in oxidation number, we multiplied by 2. So we will write 2 here and 2 here. Okay, so our equation becomes 2MnO4 minus plus Br minus converting into 2MnO2 plus BrO3 minus. Okay. Now step 4. Balance the ionic charges. Now this reaction is taking place in basic medium. So to balance the ionic charge, we add the 2 OH minus. We will add the OH minus. Okay. Now just we will find out how many OH minus ion and to which side. First calculate the charge on both the side. This is MnO4 minus. Each MnO4 contains one negative charge, but they are the 2 MnO4, so 2 negative. In case of Br minus, 1 negative. So we can say total charge on the reactant side is minus 3. In the product side, MnO2 is a neutral and BrO3, this is 1 negative. This is minus 1. Reactant side minus 3, product side minus 1. So how many OH to which side? In the product side, we will add the 2 OH minus ion. Okay, so our net equation becomes 2 MnO4 minus plus Br minus converting into 2 MnO2 plus BrO3 minus plus 2 OH minus. Clear? Now balance hydrogen atoms. And to balance the hydrogen atoms, we have to add water, H2O. Again calculate the hydrogen atoms on both the side. In the reactant side, no hydrogen atom is there. Okay, in this. But in the product side, if you see, 2 hydrogen atoms are there at this place. Okay, so we have to make 2 hydrogen atoms in the reactant side, that is in left side. So we will add 1 H2O on the left hand side. So our final equation is balanced equation. 2MnO4 minus plus Br minus plus H2O converting into 2MnO2 plus BrO3 minus plus 2OH minus. Okay? Thank you. Subscribe my channel to get the next video from this redox reaction. And in the next video, we'll discuss the another method of balancing of redox reaction.